Okay, so an ellipse is the set of all points in a plane such that the sum of the distance from two foci now, that's plural for focus, is constant. So remember when we had a parabola, we had a focus in the middle of it. Okay? Pretty much now what we have, so we had a parabola with a focus in it. Now pretty much what we have is we have another one and they're faced the same direction. So think about it as an oval. And the distance around that ellipse is the constant, the same time. So from this point to my ellipse to that point is the same the whole way around when I add those two up. Okay? Every ellipse has two axes of symmetry. So I can fold it in half two different ways. I can fold it in half the long way, and that would be the major axis, and a minor axis. So that would be like the short way there. We can also have ellipses that are tall and skinny. So we can have short and fat ones, and we can have tall and skinny ones. Okay, the standard form of the equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, notice that looks similar to a circle. Remember, our circle was x minus h squared plus y minus k squared equals r squared. So instead of equaling our radius, now this guy equals 1. And we have these denominators. These are important, and these are what we're going to use to graph them. But just like a circle, the center is still at h comma k. Now, I'm going to go through a whole bunch of information about how to find the foci and stuff like that. I just want to give you some background information. What I'm only going to ask you to do is to, on your get to your homework, you're going to just have to write this guy in standard form. So you're going to take the equations, we're going to write them in standard form, and then we're going to sketch a graph. But I want you to see where those foci points come from. You also have your formula sheet. So grab your formula sheet. If you're in the classroom, there's a stack of blue ones up front if you need another one. But on the back side of your formula sheet, there's a whole thing about ellipses. Like I said, I'm just going to make you put it into standard form and then graph it. Okay? In previous years, we went through all of this stuff, but in an attempt to make your life less horrible and crazy at the moment, let's just put them into standard form and graph them. Okay? So, to find the foci, they're ordered pairs, they're coordinates. We use a formula called b squared equals a squared minus c squared, where b squared is the smaller number. So he's the smaller denominator. Then we solve for c, and then we add and subtract that to the center. So pretty much what we do is we start with an ellipse. We graph its center, and then we'll say, okay, here are the foci. Now, like I said, we're not going to do that. We're just going to write them into the correct form, and then we're going to sketch their graph. Sound good? Okay, questions so far? Okay, so let's look at number 1. Number 1 says find the coordinates of the center and the foci and the lengths of the major and minor axes. So we're going to find the coordinates of the center of the ellipse with our equation x squared over 36 plus y squared over 9 equals 1, and we're going to graph it. Okay, so we don't quite have h and k, so let's just throw some zeros in so you can see it. So I just put a couple zeros in there for my h and my k. So x minus 0 squared over 36 plus y minus 0 squared over 9 equals 1. Okay, so my center is at 0, 0. Remember, h comes with your x, y or k comes with your y. All right, so I'm going to graph this guy at 0, 0. The denominators tell me how far to go when I'm graphing this guy. So under the x, in the x direction, I'm going to go the square root of 36. So the square root of 36 is 6. So I'm going to go 6 units to the left, 6 units to the right when I sketch it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, in the y direction, I'm going to go the square root of 9. The square root of 9 is 3, so I'm going to go 3 up, 3 down. So the denominators tell us how to make that shape. So we take the square root of the denominator under the x, that tells us how far to go left and to the right. The denominator of the y tells me how far to go up and down. And then you can just connect the dots. Now, they're not pointy, they're more round and curved, just like circles, they're not diamonds. It's okay if they look like potatoes. Okay, questions on graphing an ellipse? Okay, number 2. Number 2 says find the coordinates of the center and the foci. Again, on the lengths of the major and minor axes of the ellipse with the equation x plus 1 squared over 64 plus y minus 2 squared over 81 equals 1. This guy is in the correct form. We've got him with our h and our k. We've got denominators. He equals 1. Okay, so where's my center? Remember to flip the sign of those numbers when you take them out. Just like when you found the center of the circles, we flipped the sign and we took it out when we took it out of the parentheses with the variable. So where's my center of my ellipse?
-1, -2.
Close.
-1, 2.
There you go. Thanks, JJ. So my h was -1. Go ahead. Yes, JJ.
Well, on the
Right. Yes. Okay, so when we had parabolas, notice when we had a parabola, he didn't have a variable. Like he was just a number hanging out, right? So we flipped the guy that had the the variable with him, this guy stayed. So anytime it's got a variable with it, flip its sign. Yeah, good question. All right, -1, +2. Okay, now I'm going to look at my denominators. Under my x variable, I have a 64. So I'm going to take the square root of 64. So if I go to the left and to the right, how many am I going to go? Perfect. So start at your center, go 8 to the left and 8 to the right. Perfect, yes it does. So in the y direction, I'm going to take its denominator, take the square root. Square root of 81 is 9. So this guy is going to be 9 up, 9 down. This guy looks more like a circle. 8 and 9 are pretty close. Okay, so it's okay. Some ellipses look kind of like a circle when we graph them. So I'm going to go 9 up. 1, 2, 3, 4, 5, 6, 7, 8. Oop, off my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. He's just a touch taller than he is wide. Okay, so those ones, they were in the nice pretty form. But guess what? Just like circles, we're not always given them in the nice pretty form, right? Unfortunately. So turn the page. So number 3 there says, find the coordinates of the center, and then it says find the foci and the, excuse me, the lengths of the major and the minor axes. Well, again, let's not do that. But this guy right here is not in the form that we want him to be. Okay? Notice we have an x squared, a 4y squared, minus 6x minus 16y minus 11 equals 0. So we have a plain old x term, we have a plain old y term, and we need to, how do we put it in the right form? What should we do? What'd you do with circles? What'd we do with parabolas? Complete the square. Perfect. Thanks, Griffin. When we complete the square, how many times are we going to have to complete the square with this guy? Twice. Thank you, Zoe. Also notice when we complete the square that we have a 4 in front of our y squared term. So we're going to have to trick that guy. So I'm going to have to divide that guy by 4 and that guy by 4. Okay, so here we go. X squared minus 6x. I got to put the x's together. I'm going to add in my box. All right, I'm going to put the 4 out front. Y squared. He's now minus 4y. Plus, I'm going to use a triangle. You can use whatever shape you want. Equals, I'm going to add my 11 over. Preserve equality, so you've got to add a box. we also have to add a triangle, but in front of our triangle, we also have to have the 4. Don't forget the 4 in front of your triangle. Okay, now we have to complete the square twice. So we're going to use this guy right here. Remember, to complete the square, we're going to take our b value, that 6 right there, divide it by 2, and then square it. Now technically it's a negative 6, but it doesn't matter because when we square him, he'll always be positive. So 6 divided by 2. Square it. Awesome. Okay, now we're going to use this guy, 4 divided by 2. Awesome. Thank you, JJ. Square it. All right, here we go. Remember, we're forcing it to factor with the 2 exact same factors. X, keep the first sign, square root the box. All right, so I have x minus 3 squared plus 4 times y minus square root your triangle squared equals 11 plus 9 plus 4 times 4. Awesome. Thank you, Zoe. Well, it looks close, right? We've gotten it sort of close, but now we have this 4 hanging out front. And that's not quite what we wanted. And it also equals 36. So this guy sort of looks like a circle, but not with this 4 hanging out front. So I got to get this guy to equal 1. What should I do? Okay, so I could divide it by 4, but then he would turn into a 9. I don't want him to equal 9. Yeah, we want this guy to be a 1, right? So in our formula, we want this guy to be a 1. So I could divide by 4. That would get rid of that 1 out front, right? This guy right here, but then he would still equal 9, and that's not quite what I want. So I do need to divide everybody by 36. But when I do that, I have to reduce that guy as a fraction. So x minus 3 squared over 36 plus y minus 2 squared over 9 now equals 1. So that got rid of the 4 out front. It also put it in the nice pretty form that I want with where it equals 1. Yes, even if it's super duper big. So you'll always divide by this number here as long as there's numbers out front. Does that make sense? I don't want to confuse you with circles, but if you have a coefficient out front, whatever number this is, you're going to divide it. Sometimes there'll be a number in front of both of them, and then that's why it makes that number over here bigger, JJ. Okay, so we've got him in the form that we want him. The other thing you might see too is you might see the y's and the x's flipped. Remember, when it's addition, it doesn't matter if we have x plus y or y plus x. So be careful when you find h and k. Most of the time x will be first, but sometimes it won't. It just depends on what it's telling you. I'm making the screen bigger for the kids in the room. So hold tight. Okay, so let's try to graph this guy. So where is my center? Perfect. Thank you, Wyatt. 1, 2, 3, 1, 2. Okay, so now in the x direction, take the square root of the denominator that's under the x. Awesome. Go that left and right. Okay, your y direction. Take the square root of its denominator. Yay! 3 up, 3 down. So we can look at our standard form. Mine kind of looks like an eyeball, that's okay. We can look at our standard, once we get it into the right form, we can look at it and say, hey, that guy's going to be short and fat or tall and skinny. Okay, if your x denominator is bigger, this guy's going to be longer. He's going to stretch it out in the x direction. If your y denominator is bigger, it's going to stretch it out in the x direction. So I can look at this guy and say, okay, he's going to be short and wide. Because I know, looking at my denominators, that the square root of 36 is going to be bigger than the square root of 9. Okay? We're not going to work backwards, and I'm not going to make you write an equation from a picture or any of that sort of stuff, so we're actually going to skip 4 and 5 in your notes. Go ahead and cross them off. Do you have questions about putting equations into standard form or graphing the ellipses? Okay, then let's turn the page and look at your worksheet because I want to make it easier for you. The only thing I want you to do with these guys is to tell me the center and to graph them. So you don't have to do any of this major minor axis stuff. Okay, so all you have to do is find the center and then graph it. So number 1, there's in the right form. Tell me the center, graph it. Number 2, he's in the right form. Center, graph it. Number 3, let's look at number 3. Is that guy in the right form? Sort of, but not really, right? I mean, we don't have to complete this square because I don't have a plain x term and I don't have a plain y term, but he's not in the right form yet. So what I'm going to do is divide everybody by 81. Again, you still don't have to do this, Jazz. Okay, now here I go. I'm going to throw in some zeros so he gets prettier. And then we'll fix our denominators. I gotta grab my calculator. You have two options when you do this. You can reduce it as a fraction. Remember, we can use that fraction button in our calculator. So I can do green and then y equals. And I can do 27 over 81. Okay, that's one option. It's going to show up as a fraction, or 1/3. The other option is you just take your denominator and divide it by 27, and I get 3, and that would be my denominator. Does that make sense? You should not end up with fractions, though, in your denominator. So just be careful. So then 81 divided by 9 is 9, or 9/81 is 1/9. Okay, you didn't have to complete the square on that, so you're just going to tell me your center and then graph it. Okay? All right, next page. Number 4, you're going to do that exact same thing. Divide everybody by, 32. Okay, so we haven't completed the square yet. Number 5, that is the very first one where you're going to have to complete the square twice. So you need to rearrange it. You also have a 4 in front of the y squared. Number 6, that's another one where you need to complete the square. Again, with all of these, you don't have to do this, Jazz. Okay, turn the page. Hopefully those ones go fast. 7, 7, you're going to complete the square. Find the center and graph it. 8, complete the square, center and graph it. 9, complete the square, center and graph it. Okay. Questions on ellipses?